Hello everyone, my name is Aishwarya and my roll number is 220103004. In this presentation, I will show how Fourier analysis can be used to uncover hidden pattern and electricity demand data. Electricity consumption changes throughout the day because of the human activity and industrial usage. However, these patterns are not always clearly visible in a raw data. So, the goal of this project is to apply the Fourier transformation to reveal the underlying periodic patterns in electricity demand. Many real-world signals contain repeating patterns, but these patterns are not always obvious when we look at the signal over time. Electricity demand varies throughout the day due to the factors such as work hours, residential usage, and nighttime reduction in consumption. When plotted in the time domain, the signal may appear irregular or noisy. So, the main question of this project is, can Fourier analysis reveal the hidden periodic cycle in the electricity consumption data? The Fourier transformation is a mathematical method used to break a complex signal into simple sine and cosine waves. In simple terms, it converts a signal from the time domain to frequency domain. This means that instead of observing how the signal changes over time, we analyze which frequencies are present in signal. This helps us to identify repeating cycle or the periodic pattern that are difficult to detect in the time domain signal. In this project, we followed a computational approach. First, we obtained the electricity demand data recorded over time. Next, we treated the demand value as the time series signal. Then, we applied the fast Fourier transformation, which efficiently computes the Fourier transformation for the discrete signal. Finally, we calculate the amplitude spectrum to identify the dominant frequency component in the signal. This analysis was implemented using Python. We used NumPy to compute the Fourier transformation and Matplotlib to visualize the result. First, we load the electricity demand data, then we compute the Fourier transformation using the FFT function. After that, we calculate the magnitude of Fourier coefficient and plot the amplitude spectrum. This allows us to visualize the frequency component present in the signal. This slide shows the electricity demand plotted against the time. We can observe the fluctuation as the electricity uses change during the day. However, the repeating pattern is not clearly visible because of the signal appears somewhat irregular. This shows that analyzing signal only in the time domain may not clearly reveal the hidden patterns. This slide shows the frequency spectrum obtained using the Fourier transformation. The horizontal axis represents the frequency and the vertical axis represents the amplitude. We can see clear peaks at a certain frequency. These peaks represent dominant periodic cycle in the electricity demand. For example, a strong peak corresponding to a 24-hour cycle reflects the daily electricity usage pattern caused by human activity. From the frequency spectrum, we can clearly identify the main periodic cycle present in electricity consumption. These cycles correspond to a real-world pattern such as daily routine and working hours. Thus, Fourier analysis helps reveal the hidden structures in the signal. Fourier analysis has many important applications in engineering. It is used in the power system analysis, vibration monitoring, audio signal processing, and the communication system. It is also widely used in biomedical signal analysis such as ECG and EEG signals. In conclusion, This project demonstrates how Fourier analysis can reveal hidden periodic patterns in electricity demand data. By converting the signal from the time domain to the frequency domain, we can clearly identify dominant cycle in the electricity consumption. This shows the power of frequency domain analysis in understanding the real world signals. Thank you.